A charge is often laid at the door of the large language models, or LLMs, that they rely on probabilistic generation, assuming that this is somehow a bad thing, and that a more deterministic behavior would somehow be a better idea for the future artificial general intelligence, or AGI. Before the advent of the LLMs, almost all practical computer systems followed deterministic logic encoded in their software, but as I will argue in this episode, the future AGI will be neither deterministic nor deductively logical. Thank you for listening and subscribing. I am Alex Chaduk, and this is AGI. Listen every Monday morning on your favorite podcast platform. Imagine in some not very distant future an AGI robocop is patrolling the street at night. Suddenly there is a sound of broken glass and a burglar alarm heard from around the corner. In a blink of an eye, the robocop is at the scene and sees a gentleman wearing a mask crawling out of a broken shop window, carrying a bag full of expensive jewelry. We would certainly expect that the robocop should immediately arrest the gentleman in the mask, but would that decision be the outcome of a deterministic logical deduction from the observed evidence? Certainly not. The gentleman may well try to explain that he is the owner of the jewelry store. He is wearing a mask because he was returning from a masquerade party. He saw a passing truck throw a stone into his shop's window. He did not have the key to his store on him, so he had to collect all the jewelry to protect it from an inevitable theft until he was able to fix the window next morning. He may even ask the robocop to escort him to the train station so that he is not robbed on the way. This all may well be true, and in the absence of any other evidence one way or the other, the logical behavior for the robocop in this situation could be to say, "You are absolutely correct," and see that he gets to his late train safely. And yet, this is not the way that we expect that the robocop should behave in this situation. Although the strict logic does not allow us to resolve the problem deductively one way or the other, we still expect the robocop to behave based on common sense. In this case, as in virtually any other real-world situation where the full information is not available, we must rely on much weaker form of reasoning that we call plausible reasoning. So we see that the AGI system cannot be deterministic simply because it never has full information. But what we should demand instead is that the reasoning that the robocop applies to the problem is internally consistent. We have discussed in the previous season that the LLM behavior we observe today is inconsistent, and that the claim of reaching the artificial general intelligence, or AGI, cannot be accepted until the system can be shown to reason consistently. Let's explore how consistent reasoning under imperfect information should work. But first, let's start with a quick look at the strict deductive reasoning using a logical syllogism. A classical syllogism that you might have heard many times before is this: all men are mortal, Socrates is a man, therefore Socrates is mortal. The syllogism starts with a major premise: if A is true, then B is true. So in our case, if subject is a man, then subject is mortal. The minor premise is A is true. In our case, subject Socrates is a man. And the conclusion of the syllogism is that B is true, that is, subject Socrates is mortal. Another form of strong deductive syllogism is a contraposition. Starting with the same major premise, if A then B, the contraposition is defined by the minor premise that B is false. For example, subject Zeus is immortal. Then the conclusion is that A must be false too, subject Zeus is not a man. This is how strict deductive reasoning works. But once we allow to have statements A and B in our syllogism to be neither perfectly true nor perfectly false, in other words, we allow some form of uncertainty about these statements, how can we continue to reason about them consistently? We can consider a weaker form of syllogism, again starting with the major premise, if A then B, we declare an observation that B is true. For example, we say that subject Sparks is mortal. Can we jump to a conclusion that A is true too, that is, subject Sparks is a man? Of course not. But if we consider the multitude of objects in the universe, and we assume that we know nothing about what subject Sparks is, we can say that there is some plausible chance that Sparks is a man, because there are quite a few objects in the universe that are men. Now, when we learn that Sparks is mortal, because we already know that men are mortal too, this knowledge makes it more plausible for us that Sparks is a man. But the main point here is that consistency of our reasoning does not allow us to reduce the level of our conviction that Sparks is a man when we find out that he is mortal. That would be inconsistent with the rest of the things that we know to be true. So the main premise is still if A then B, the minor premise is B is true, and the logically consistent conclusion is that after observing that B is true, we can say that A becomes somewhat more plausible. It is still by no means certain. The same set of statements would still be true if Sparks were a dog. Now we can consider an even weaker form of syllogism and see if we can still reason about it consistently. Starting with the same major premise, if A then B, we can now try to assert that A is false. For example, that subject Hercules is not a man. Does that mean that Hercules is immortal? Again, taking no knowledge about Hercules as a starting point, finding out that Hercules is not a man kind of increases the chance that he is an immortal god, but by a very, very tiny degree. He might as well be a cat and therefore sadly mortal. So this weak syllogism starts with if A then B, and an observation that A is false makes it a tiny bit more plausible that B is false too. The important thing here again is that our consistent reasoning does not allow us to say that all men are mortal and at the same time claim that after we learn that Hercules is not a man, we become more convinced that he is mortal. Although we talk of tiny changes in our assessments of the plausibility of uncertain statements, we simply cannot say that we become more certain that Hercules is mortal after we learn that he was not a man, because that would be inconsistent with our knowledge that all men are mortal. So, the way that AGI can stay consistent in its reasoning is by deliberately avoiding inconsistency. At the same time, you see how incredibly weak our reasoning becomes as we move away from the strong forms of logic into the real world of uncertainty. But now I will show you that when the robocop confronts a masked gentleman with a bag full of jewelry, the robocop follows an even weaker form of syllogism. The main premise is no longer if A then B, it is if A is true then B is more plausible. In our example, the major premise is if the gentleman is dishonest, it is more likely that he will be crawling out of broken windows of jewelry stores. It is by no means certain a dishonest gentleman may find other ways to entertain himself on a rainy evening, including perfectly innocent ones. And it is not that an honest gentleman cannot find himself crawling out of a broken window carrying jewelry. It is possible, it is just that in our experience it is less likely. So we start with a major premise that if A is true then B is more plausible. The minor premise is the observation that B is true, the gentleman does indeed crawl out of the broken window. The consistent conclusion of this syllogism used by the robocop is that an observation that B is true makes A more plausible, meaning that the gentleman is more likely to be dishonest. We have talked today about how AGI can stay consistent through skillful avoidance of inconsistency and how consistent reasoning can change our assessments of plausibility of uncertain statements, but we have so far did not discuss how we can measure plausibility. This will be the subject of a future episode. With this, until next Monday, my friends, I am Alex Chaduk, and this is AGI.